Hi everyone, welcome back to VRC Smart Edu channel. So today we are going to see the new chapter of chemistry, class 12 new chapter. It is going to be chapter 10 Haloalkanes and Haloarenes. So it is a 10th chapter from the part 2 book. So it is going to be the organic chemistry. It's a part of first chapter of organic chemistry. Organic chemistry. So this is the first part that we are going to discuss. So it is going to have today we are going to discuss the introduction part of haloalkanes and haloarenes, classification as well as nomenclature. These three things we are going to see today. Okay, are you ready to see today? Yes. Hope you are ready. Let's dive on to today's video and look all these things in detail. So first, let us deal with the introduction part. Haloalkanes and haloarenes. What is haloalkanes and what is haloarenes? Okay. First, what is the meaning of halo? Halo means halogen. Halo means halogen. Halogen means we have certain compounds called halogen compounds. So that is halogen compounds is represented with the symbol X. That is nothing but chlorine, bromine, iodine and fluorine. These are your halogen compounds. Okay. Halo represents these halogen compounds. What do you mean by alkanes? Alkanes means you know that alkanes comes under the hydrocarbons. So methane, propane, right? Ethane, you have read about that. Carbon will be there and four hydrogens will be attached with single bonding. It's called as methane. Like that, ethane means two carbon molecules, so with hydrogen bonding, this is ethane. So this is called as the alkane. Alkanes are represented with the symbol R. Okay, so now what is the definition you can write for haloalkanes? Now, what is the definition you can write for haloalkanes? Just look here. Haloalkanes can be represented as Rx. That means, see in R, I told what is R. R is nothing but one carbon or two carbon, any number of carbon attached with certain hydrogen bondings. So here hydrogens will be attached. So what you are going to do in haloalkane is you are going to remove one hydrogen. Instead of one hydrogen, you are going to place normally one hydrogen. You can remove n number of hydrogens. Instead of hydrogen, you are going to place your this halogen group. Either chlorine or bromine or iodine, you are going to place it instead of hydrogen. That is called as haloalkane. So you can simply write it as, you can simply write the definition as replacement of hydrogen bond or hydrogen atom, replacement of hydrogen atom by halogen atom in hydrocarbon. In hydrocarbon is called as haloalkane. So haloalkane is represented as Rx. Haloalkanes can also be called as alkyl halide. Haloalkanes can also be called as alkyl halide. Okay, alkyl halide. Now, what is all about haloarenes? What is all about haloarenes? Now, this is example I gave you for haloalkane. Now, haloarene is nothing but it is arenes. It is also attachment of halogen in the arenes. Arenes is nothing but aromatic rings. Aromatic rings. Aromatic rings, what is the example of aromatic ring? C6H6 is an example of aromatic ring. That is nothing but it is benzene. So in the benzene, what happens? If you are having the benzene, in the benzene, you have one hydrogen attached. See, if three double bonds will be there, everywhere hydrogen will be attached. Right, everywhere hydrogen will be attached. So here one hydrogen will be replaced by either chlorine or bromine. Not only one hydrogen, any number of hydrogens can be replaced by chlorine, bromine, iodine. That means it is called as haloarenes. So haloarenes, simply how you can write the haloarenes? How you can write the haloarenes? You can write the haloarenes as benzene ring with X attached. The X can be chlorine, bromine or iodine. So how you can say is here also replacement of H atom by X atom in benzene. So this can be written as aryl halide. So what is another name can be given to this is aryl halide. Okay. Aryl halide. Clear everybody? So this is a basic thing that you have to know about haloalkanes and haloarenes. Now moving on to the next. Applications of halogen in day-to-day life. So application. So what you will think about application? Application means how this haloalkanes, that is halogens, is used in our day-to-day lives. Already we discussed what is halogens. That is chlorine, bromine, iodine and fluorine. How these compounds are used. Now let us see the applications. See, in the application you have, just observe here carefully, iodine. So our body is having the ability to produce, naturally the iodine. Iodine is also one of the halogen atom, right? So iodine our body will produce. It is produced by the hormone, thyroxine. So the deficiency of this thyroxine will cause goiter. Okay, we already studied this in our biology in class 11, right? So the deficiency of the hormone that is going to produce iodine in our body, if there is going to be the deficiency in that hormone, it is going to cause goiter. Clear? Similarly, if you come here, chloramphenicol. Chloramphenicol is extracted from the microorganism. It is extracted from the microorganism. So this one is helpful for treating typhoid. Similarly, if you just see here, chloroquinoine. Chloroquinoine, it is also helpful for treating malaria. Chloroquinoine is helpful for treating malaria. Similarly, the next one you have is halothane. Halothane. So in the word itself, you know that is made up of halogens, right? So halothane is used for as an anesthesia. Anesthesia during the surgery. So during the surgery times, it is used as anesthesia. Clear. Next you have the fluorinated compounds. Fluorinated compounds are used as blood substitutes. So fluorinated compounds. Okay. Clear, everybody? So these are the applications of uh, in our day-to-day life. Applications of halogen in our day-to-day life. Clear? Now let's move on to the classification. So how do you classify? So classification is very important. Listen carefully. Okay. Classification. I am going to classify the haloalkanes and haloarenes classification. I am going to divide it into three different categories. Three different categories. First one is going to be monohalogen derivatives. Monohalogen derivatives. Second one is going to be dihalogen derivatives. Third one is going to be trihalogen derivatives. Trihalogen derivatives. Okay. So in the monohalogen derivatives, what is monohalogen derivatives? That means you just see mono. What is the meaning of mono? Mono means one. So one halogen will be there. That is called as monohalogen derivatives. Okay. Only one halogen will be there. That is called as monohalogen derivatives. CH3Cl is an example in case of haloalkane. In case of haloarene, the benzene ring, okay, benzene ring attached to one Cl. This can be the example for the monohalogen derivatives. Dihalogen derivatives means automatically what happens? Two halogen will be there. Okay, CH3, CH. Then you can have two Cls attached. Okay. Similarly, here also. Here also two Cls will be attached. So this is an example. Trihalogen derivatives, how it will be? How you can write the example for trihalogen derivatives? CH2, CH2, CH2 you can write, and Cl will be attached. So three Cls are attached, right? Similarly, when you talk about the benzene ring also, three Cls can be attached. So this is your trihalogen derivatives. Now, when you talk about the monohalogen derivative is divided into two. Divided into two. One is sp3 hybridization. That means it will be having the single bond. Another one is the sp2 hybridization. sp3 hybridization, sp2 hybridization. There is a carbon should have sp3 hybridization attached to the halogen. sp2 hybridization attached to the halogen. sp2 means it is double bond, you know. sp3 single bond. Now, this sp3 hybridization is divided into three types that we will see on the next slide. Okay, divided into three types. sp2 hybridization is divided into two types. Now let us see the two types, the three types. See here, see clearly. I told sp3, sp3, sp2. So sp3 hybridization is divided into three types. sp2 hybridization is divided into two types. Okay. See, sp3 hybridization, it's divided into alkyl halides and allylic halides and benzylic halides. I told it's divided into two. One is vinylic halide, another one is aryl halide. So we are going to read about this alkyl halide and we are going to read about this aryl halide in detail. Okay, in this lesson. Now, Coming on to the next level of division. Before that, let's see the examples of each and everything. So example of alkyl halide. So alkyl halide, already I told it's going to be Rx. Already we studied some examples for alkyl halide, right? Allylic halides. Allylic halides, how you can write about the allylic halides? So you have the double bonded carbon system, but your that is your Cl is attached to the carbon that is having sp3 hybridization. Clear? Then benzylic halide. Benzylic halide is normally to the benzene. To the benzene, your halogen will not be directly attached. So it will not be directly attached. See how it is attached. Carbon will be there. To the carbon, one halogen group will be attached. So other bondings with hydrogen it will be having. Clear? This is your benzylic halide. Then vinylic halide. So let us see the difference between allylic halides and vinylic halides. If you see the allylic halides, the double bonded carbon system is there, but the chlorine is attached to the carbon that is having the single bonded carbon system. Clear? But here, to the double bonded carbon system, directly your halogen atom will be attached. Okay. And in aryl halide, to the benzene ring, directly your X atom will be getting attached. Okay. Now, very importantly, you're going to see that your alkyl halide is going to divide into 3, and your benzylic halide is going to divide into 3 types. Okay. So your alkyl halide divisions are nothing but it's going to be primary halide, primary alkyl halide, secondary alkyl halide, tertiary alkyl halide, primary benzylic halide, secondary benzylic halide, and tertiary benzylic halide. Now let us see the examples of it. Before that, you should understand what is primary, secondary, and tertiary. So what is primary? Primary is nothing but, see, tertiary is only one carbon will be there and hydrogen four bonds are formed around the carbon is called as tertiary, and this is secondary. Only one CH will be there, one bond with hydrogen, and the rest of the bonds will be like this. So this is your secondary carbon, and if it is going to be tertiary carbon, CH2 bonding with any other two bonds. This is your primary carbon. So let us now see how it is possible. Examples let us see for the given. So primary, for this I am giving the example first. See, primary you can write it as CH3, CH2, CH2, Cl, because CH2 is nothing but its primary compound, right? So now I am writing the example for the secondary compound. Secondary compound can be CH3, CH, or I'll write it in clear format so that you can understand. One second. Uh, One second. I'll make it clear. So I told it's divided into 3. First one is going to be primary, second one is going to be secondary, and third one is going to be tertiary. So now it will be easy for us to classify. So primary can be, I'll rub this also. So also we'll make it in the same sense. Okay, right. So what is the example we can give for primary? We can give CH2, CH3, CH2. Then you can attach CH2, CH2, Cl. Right? This can be your primary. Right? So next, then what you can do? Then here CH3, CH, Cl. Here CH2, CH3. This is going to be your secondary carbon, right? Then tertiary. Tertiary, how you can write it as? Tertiary, how you can write it as? Or here itself you can finish with this. You can write also. I am going to finish it up to this CH3. Next, you can have the tertiary carbon. So carbon, 4 bonds will be attached. One of them is chlorine and another with carbon, other carbons I am going to fill it. So that's it. Now these are the examples for your alkyl halides. Now moving on to aryl halide. So as I said, aryl halide is also having primary, secondary and tertiary divisions. Okay, now let us see the examples of each and every thing. Okay, so how the primary will be classified? Primary will have the benzene ring. I told that for primary means your C will be attached, CH2 should be there, one bond here already, 2 bonds, 3 bonds and fourth bond with X. It can be chlorine. Okay, next benzene ring with this is a secondary carbon, so CH should be there and one bond with Cl. So 1, 2, 3 bonds already over, so fourth bond you can give anyway, that is going to be CH3. And now it's going to be the tertiary carbon. So tertiary carbon in the sense here only C should be there, Cl should be attached. So here also CH3, here also CH3 to be attached. This is the classification. See, classification is really easy only. So you have to remember how you have to classify. So what is the monalo derivatives? Vinylic halide means what? Aryl halide means what? Allylic halide means what? All these things you have to do. Compare and study so it will be easy for you. Clear? Okay. Next, moving on to the next. Next, we are going to talk about the nomenclature. So usually nomenclature will be very easy, but you have to understand. So in our previous classes, we have done the nomenclature, only the IUPAC name we have given. But here we are going to learn both IUPAC name and common name for some of the compounds. That is going to be very, very important. Okay. So be clear and try to understand these compounds are very, very important. Okay. So just see here. CH3Cl. See, CH3Cl is a very famous compound. Its common name is chloroform. Chloroform. Its IUPAC name is, you see how many carbon? Only one carbon. Okay, so 3 chlorine is there. So it can be written as trichloromethane. It can be written as trichloromethane. Clear? Then CCl4. It is going to be the very, very most famous compound again. It is nothing but carbon tetrachloride. Its common name is carbon tetra CH chloride. So tetra in the sense 4. So 4 chlorine is there. So carbon tetrachloride, and its IUPAC name is going to be tetrachloromethane, because only one carbon is there, so it is tetrachloromethane. Okay. So very good. So now these are the very important and common you have to be very clear with. Now moving on to the next compound. Next one is in the form of the benzene ring. You have to name it in the form of the benzene ring. So how to name this compound? Okay. So being very clear with this. See, common names in the benzene compounds, you have to mention it with the positions. You have to mention it with the positions. So positions are really important. So you see the benzene ring is there here. So to the benzene ring, if any two compounds are attached, any two X compounds are attached in this position, this is called as ortho. Ortho is represented with O. And to the benzene ring, If anything is attached at this position, okay, ortho, then clearly understand. If anything is attached, 1 minute, let me draw the benzene ring again. Okay, anything is attached in this position, it is meta position. And so you have to be very clear with these positions. Clear? So now it is attached in this position and this position. That means it is in ortho position. So it is nothing but its name, common name is ortho chloro, and CH3 is attached. CH3 with benzene ring is called as toluene. So toluene. So orthochlorotoluene is the common name. IUPAC name is 1-chloro 2-methyl benzene. You can write it as, or you can write it as 2-chlorotoluene. Anyway, so I am going to write it as 1-chloro 2-methyl benzene. Okay, so I am going to write it in this way. Now, coming on to the next compound. So, next compound is having the carbon in the tertiary position. So, this is a tertiary carbon, right? Anything can be attached, but only one carbon is there, so it's a tertiary carbon. So, how do you name this compound? It's a tertiary carbon, and 1, 2, 3, the highest carbon chain is what? The highest carbon chain is going to be the propane. Highest carbon chain is going to be the propane. Clear? So if you see here, it's coming under the, you all know, tertiary. So now let us see here. So common name. So if you just look after here, the common name will start with tertiary because carbon is tertiary carbon. So tertiary, T-R-T-S-N-I, tertiary. How many carbon is there? 4 carbon is there. So you have to write here butyl only. So butyl chloride, tertiary butyl chloride. You know how to write the IUPAC name. So IUPAC name is 2-chloro. So you have to name it like this only. The highest carbon chain. So 2-chloro 2-methyl 2-chloro 2-methyl propane. So few more compounds also we have. Let's try to name these compounds first. Okay. So again coming to the next one. So IUPAC name and common name you have to give for this compound. Okay. So what is this compound? Look after the first compound here. So the first compound, how you have to name this compound? Here the common name is going to be a bit tricky because here you can able to see that we have studied about the halides, right? So when two chlorides are attached together, so it is called as gem dichloride. Dichloride is the common name. And what is the IUPAC name here? Easily you can name the IUPAC name. That is going to be 1,1 dichloroethane. This is the IUPAC name. Now here if you see this, you have two chlorines attached to two different carbons. So this is called as vinyl dichloride. So same carbon, if two chlorines are attached, then it is gem dichloride. If two different carbons chlorine is attached, then it's going to be vinyl dichloride. hexynyl dichloride, and its IUPAC name is going to be 1,2 dichloroethane. 1,2 dichloroethane. Now I told that based on the positions of the benzene, we will classify the benzene into ortho, meta and para position. So already I said if the two compounds attached in this way is going to be meta positions. So you write meta or M. Just simply represent the first letter M. Dibromo. Two bromines are there. So dibromo benzene. So for this, what will be the IUPAC name? Is the first position, second position, third position. So 1,3 dibromo benzene. Okay. So here what will be the common name and what will be the IUPAC name? So what will be the common name here? See, bromine is attached on the three sides. So when you divide this bromine into two equal halves, one half will resemble the another half. That is, both resembles the same. So it is symmetric in nature. So you write SYM that represents the symmetry. Tribromobenzene. Tribromobenzene. Okay. While you are naming in IUPAC name, you have to number the compound 1, 2, 3, 4, 5. Right. So it is going to be 1, 3, 5 tribromobenzene. Clear? Right. Now moving on to the next compound. Here also you are supposed to give the IUPAC name and common name. Clear? Right. So see here. Okay. So now listen. Your chlorine is attached to the second. So you see three carbons are there. Your chlorine is attached to the second carbon. It's forming the iso group. So you will write for the common name. You can write iso. How many carbons are there? Three carbons. So isopropyl chloride. It is the common name. What will be the IUPAC name here? The IUPAC name is 1, 2, 3 carbon is there. So it is propane, and to the second carbon what is attached? To the second carbon chlorine is attached. So 2-chloropropane. Right? Then now if you just see here, bromine is attached at the first position. Wherever bromine is attached, that is the first position here. So this is going to be the first position. Then it's going to be bromobenzene. Both IUPAC name in this place and the common name is bromobenzene. Here also it is going to be bromobenzene. Clear? Right. Now look at this compound. This compound is nothing but CH3CH2Cl. So how many carbon is there? 2 carbon is there. Right? So it is going to be ethyl. The common name is going to be ethyl chloride. And the IUPAC name is going to be 1-chloroethane. Here I am going to give you an important thing. How you do write the basic thing for writing the IUPAC name and common name. Okay, note it down. So whenever you are writing your IUPAC name, in case of haloalkanes, okay, I'll give you in the. Thank you so much for watching this video. Kindly subscribe to our channel for more videos. And if you want to watch the Principles of Inheritance chapter or any other chapter, the link is provided in the description. You can go and check it out. So the preparation From that we will continue in our next class. Okay, so till then, thank you and bye.